talking about dilations, and dilation is just like that when they dilate your pupil at the eye doctor. It makes your pupil really, really large, but there's other things that can make your pupil really, really small. And so we do the same thing with figures, ladies. And dilation is the enlargement or reduction of a figure. So it makes it bigger, it makes it smaller. And the scale factor indicates how much the figure will enlarge or reduce. So scale factor, factor. Where have you heard that word before? Fractions, okay. What if I said, what are the factors of 10? 5 and 2, right? Okay. So factors are things that multiply. They multiply together. All right? And so when we have a scale factor, all we're going to be doing is multiplying things together, okay, with that scale factor. So anytime you see the word factor, it means, hey, multiply. All right? So when we say the factors of 10, it means what two things multiply to give us 10? Well, 2 and 5, okay? Also 1 and 10. So we use a K for our variable that represents a scale factor. And that K, if K is greater than 1, I'm sorry, that's a 0. I meant a 1. I said a 1. Okay. If K is greater than 1, so if K is 2 and we multiply it, what happens to our length if we multiply it by 2? It doubles. That makes it bigger, right? Okay. So the dilation is an enlargement. So if we're multiplying by a number bigger than 1, our figure is going to get bigger. If K is between 0 and 1, so let's say it's 0.5. If you multiply something by 0.5, does it make it bigger or smaller? Smaller, because 0.5 is 50%. It's half as big. So that is a reduction. Stevie, Addison, quiet please. All right. So now this represents sort of a dilation where we started with one size figure and our figure got smaller. Okay. What can you tell me about the K value if our figure got smaller? There's a reduction, but our K has to be between 0 and 1. Okay. Now, are these two shapes congruent? No, they are not congruent. So dilations don't give us congruent figures. They are clearly different sizes, and so we say they result in similar figures. All right, and I'm just going to put on the side, that means they are not congruent. All right, they are not exactly identical. Everything else we've done, reflections, translations, and rotations, we get completely congruent figures. So I see some of you on computers, and you should not be. Please be mindful. All right. So these are going to be similar. They're similar figures. They have lots of things that we can figure out. But this turns out to be very, very easy. So we're going to graph and label each figure and image under the dilation and give the new coordinates. So we'll start graphing triangle ABC. So A is at -3/4. So that is 1, 2, 3 to the left, and then up 4. 1, 2, 3, 4. So label, please, please, please. So that is point A. B is at 2, 1. So that's right 2, up 1. Label your B. And C is at -1, -5. That's left 1, down 1, 2, 3, 4, 5. So here is point C. So here is our lovely little pre-image. And our scale factor is 2. So this is our scale factor. Is this K value going to make our figure bigger, or is it going to make our figure smaller? Bigger, yeah, it's going to make our figure bigger because we're going to multiply it by 2. It turns out to be super easy. All we have to do is multiply each coordinate by 2. Times by 2. What is negative 3 times 2? Negative 6. What is 4 times 2? 8. Can we plot that point? Yeah, we can. Negative 6, positive 8 is way up here, and that is, oh wait, this is a 10 by 10 grid? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just kidding, not there, it's right here. That is a prime. This is a 10 by 10 grid, who knew? Everything else has been an 8 by 8 grid. All right, so say all we're doing is multiplying by 2. Whatever your k is, we just multiply it. So point B was at 2, 1. And if you multiply the x by 2, what do you get? 4 and 2. So there is B prime at 4, 2. 2, 4, 2. So here is B prime. And in point C, again, all we have to do is multiply the x by 2. What's negative 1 times 2? Negative 2. And then multiply the y by 2. What's negative 5 times 2? Negative 10. So then our point C is at negative 2, negative 10. That is C prime. And we can connect those ordered pairs to get a bigger triangle. What do you notice about that larger triangle, the enlargement? What does it look like? No.
Your A prime is at negative 8.
You're right. Thank you so much. Yeah, look at this. I was going for parallel lines. These two lines here, CB and C prime, B prime, they look pretty parallel, don't they? But you're right, this is graphed wrong, which is sucky. I did not realize these were, there we go. So that should be that there. Poop. All right. There we go. So there is a little better. All right. Thank you for telling me that. When we have these enlargements, it's really easy to tell if you made a mistake because all these lines should up appearing parallel, all right? And clearly this line wasn't parallel to my original pink line, where this is much better, okay? So it is quite easy to see if you made a mistake just by looking. Does it look like everything is parallel, okay? Let's try... Okay, let's go ahead and try number 3. So we're going to plot square EFGH with vertices E, which is at 8, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm actually going to count this time. All right, so here is point E at 8, negative 8. F is at 16, negative 6. All right, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6. Okay. F is at 16, negative 6. And G is at 18. All right, well, 16, 17, 18, negative 14. And then H is at 10, negative 16. Well, that's some hard counting. That was. All right, there's negative 16. All right, so I graphed my figure. Did you guys graph yours? Counting is so hard, isn't it? It's like the hardest thing It's really interesting to watch babies learn to count. It takes so long. Okay, what do I have to do with my scale factor? Essentially, divide by 2, yeah. We multiply by a half. There's a lot of ways to think about it. If I take point E, I am taking 8 and multiplying it by 1/2. And to multiply fractions, you essentially go straight across. 8 times 1 is 8. 1 times 2 is 2. So what you said, divide by 2, is essentially what we're going to end up doing. 8 divided by 2 gives me 4. And so 8, negative 8, when we multiply negative 8 times half, what's half of negative 8? Negative 4. What's half of 16? 8. What's half of negative 6? Negative 3. Good. And that's how I really like to say it, just half of something. Like, we're good at that. What's half of something? We're good at that. What's half of 18? 9. What's half of negative 14? Negative 7. Good. What's half of 10? 5. Good. And what's half of negative 16? Negative 8. Great. All right, so we can plot those points. We have 4, negative 4. E prime. 8, negative 3. F prime. 9, negative 7. And H prime is at 5, negative 8. All right. So there is our little shrink. Made our figure smaller. Questions on those? Let's not draw number 4. Instead, let's go ahead and just figure out what the points are, okay? So that you can practice multiplying by a third. So multiplying by a third is a little harder to say. What's a third of negative 18? Negative 6. Again, you can just sort of think about it, just dividing by 3. So negative 18 divided by 3 is negative 6. What's a third of 3? 1. If you wanted to, you could use a calculator. So you could just, in your calculator, do 1 divided by 3 times negative 18. You can do that in your calculator. It's pretty easy. What is a third of 0? 0. Good. What's a third of 9? 3. Good. What's a third of negative 6? Negative 2. Good. Again, another negative 2. What's a third of negative 15? Negative 5. And a third of negative 9? Negative 3. Beautiful. So again, you can use your calculator if you wanted to. It's not too hard to do, okay? Always if you need to. All right, turn the page. Is this pretty easy? Yeah, good. All right. Oh, good. Let's get down to number 10. They've already drawn half the figures first, so that's good. Okay. Oh, but I have to... Okay, well, that's fine. Graph the image. So we have the pre-image here. So we want to graph the image of the quadrilateral using a scale factor of 4/3. What do I need to know? All the ordered pairs, yeah. So this looks like 0, 0 right here. So what's Q at? Negative 9, 0? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I agree. All right. And U would be at negative 3, negative 3. Okay. A would be at 0, comma, -6. And D, 1, 2, 3, 4, 5, 6. So D is at -6, comma, I agree, -12. Okay. All right, so we know they're ordered pairs. Now becomes a little more of a challenge because we have to multiply these by 4/3. So I'm going to do some math over here, I think. How do we do -9 times 4/3? You could use your calculator. Absolutely. How do you do it without a calculator? Because it's really not that hard. Right now this is -9 over 1. And multiplying is always easier than addition or subtraction, okay? Multiplying, all we do is go straight across. All right? What is -9 times 4?
36.
-36. 1 times 3? 3. And what is -36 divided by 3? -12. So multiplying is very easy. You just have to go straight across. So make everything a fraction and then just go straight across. So Q prime is going to be at -12. What is 4/3 of 0? Still just 0. Okay, good. All right, U, we have -3. So I need to do -3 times 4/3. Again, that's a -3 over 1, and we're just going to multiply straight across. What is -3 times 4? -12 over 3, which is -4. So again, not too challenging. Those are both going to be -4. What is, right here we have a 0. What's 4/3 of 0? Still just 0. 4/3 of nothing is still just nothing. And then we have -6 times 4/3. How do you multiply? Straight across. So that's going to be -24 over 3. What is -24 over 3? -8. So we have another -6 here. That's also going to be a -8. And we have a -12. -12 times 4/3 is, again, straight across. -12 times 4 is -48. And 48 divided by 3, -16, yeah. All right, and again, I don't want to, well, okay. So -12, 0, 9, 10, 11, -12. So there is Q prime. U is at -4, -4. That's going to be right here. U prime. 0, -8. This was -6, -7, -8. So that's A prime right there. And D prime was at -8, -16. So that's -7, -8. And then -12, 13, 14, 15, 16. Right there. D prime. And what you'll see when you guys do the delta math is that these, it graphs really nice. But you can see when we graph these, all these lines appear very parallel. And if I could draw a straight line, it'd be even more parallel. So it's pretty easy to check. All right, you guys have questions for me? How do you multiply fractions? Straight across. Turn the page. Turn the page. Reflection across the x-axis. What do you have to do to reflect point C across the x-axis? Count. Yeah, we can just count. Across the x-axis means we got 2 blocks to get to the x-axis. We got to jump 2 blocks away. So here is C prime. B goes all the way across. So here is B prime. And A, we've got to count how many blocks to get to the line and the same distance away from the line. So there's A prime. The figure reflects. What about translation? What does this notation tell you to do to your figure? What does x plus 2 tell you to do? Right 2. In the x direction, we're going to add 2, so that's going to move us right 2 units. And what does the y minus 5 tell you to do? Down 5, yes. So all we're going to do is take each point and count over 2 and down 5. Right 2, down 1, 2, 3, 4, 5. Easy peasy. Right 2, down 1, 2, 3, 4, 5. Right 2, down 1, 2, 3, 4, 5. Exact same figure. Should look identical to the one that you started with. Everything just counts. Right 2 and down 5. And then last here, how do you rotate 90 degrees and counterclockwise is rotating this direction? What did I do to rotate things? Yeah, we would draw the little line. So let's say I want to rotate point C here. So starting from the origin, I make a little stick. That's going 1, 2, 3, 4 units to the right and 2 units up to get to point C. And if I take that 4 units right and 2 units up and rotate it 90 degrees, what happens to my horizontal stick? It goes up, vertical, all right? And so it would go up 1, 2, 3, 4 units up, and that stick still points the same, doesn't change. That moves horizontal now. So we got the 2 over, so here is point C prime. And that is a 90-degree rotation, okay? And that's all I really care about, that you can make your little sticks and rotate them correctly, all right? Do you guys have questions for me? Okay. Sweet.